In Module 3, Lesson 6, we're going to collect rational number-like terms in the same way that we've been using integers to combine like terms. So in the opening exercise, we're going to practice working with rational numbers. Question number 1, Terry weighs 40 kilograms. Janice weighs 2 3/4 kilograms less than Terry. We want to know what their combined weight is. So we'll need to write the expression, which will be 40 plus, because we're looking for a combined weight, the weight of Janice, which is 40 minus 2 3/4 kilograms, because it tells us Janice weighs 2 3/4 kilograms less than Terry. So we take Terry's weight, 40, subtract 2 3/4. And there's our expression. We change the subtraction to addition and change the sign of the number after it to its opposite. Then I combine the 40 and the 40 to make 80. And finally, taking 2 3/4 away from 80 will give us 77 1/4. In question 2, we have 2 2/3 minus 1 1/2 minus 4/5. Three fractions that all have different denominators, and so we need to find the common denominator for the three of them. The smallest number that 3 and 2 and 5 all go into is 30. So we'll have to make 30 as our common denominator and make each of these equivalent fractions, as well as changing subtraction to addition. So in looking at the solution, I change the subtraction to addition. 2 2/3 plus negative 1 1/2 plus negative 4/5, and then made equivalent fractions for each one. 2 20/30 plus negative 1 15/30 plus negative 24/30. Then I decided to combine the two negative terms first. And to finish the computation, if we subtract 2 20/30 and negative 2 9/30, we're subtracting them because they have opposite signs. The 2's would cancel each other, and the 20/30 minus 9/30, because this is a negative, would give me 11/30. In question 3, we're adding 1/5 and negative 4. So since they have opposite signs, we'd subtract them and keep the sign of the greater number. So negative 3 4/5 is 1/5 closer to 0 than negative 4. Our next problem, 4 times 3/5, we know is multiplication, remember, because there's no symbol between them. And in order to multiply, we need to have both of them be fractions. So we're making 4 a fraction by putting it over 1. And 4 over 1 times 3 over 5 is 12 over 5, which is 2 2/5 if we change it back to a mixed number. In question 5, Mr. Jackson bought 1 3/5 pounds of beef, and he cooked 3/4 of it for lunch. How much does he have left? The word of is a very important word in this question because it tells us multiplication. So this is 1 3/5 pounds. He cooked 3/4 of 1 3/5 pounds for lunch. How much he has left would be the 1/4 that he did not cook. So 1/4 of 1 3/5 pounds is what he has left. So we'll need to multiply 1 3/5 times 1/4 in order to find out how much he has left. 1 3/5 needs to be changed into an improper fraction. So we multiply 1 times 5, which is 5, and add 3 more for our numerator. So our numerator will be 8. Our denominator stays the same. And we are multiplying it times 1/4 because that's how much he has left. Straight across, 8 times 1 is 8, and 5 times 4 is 20. And we can simplify that fraction by dividing both the numerator and denominator by 4, which will give us 2/5. So he has 2/5 of a pound left. And then finally, in question 6, we have variables. We have 2/3 n minus 3/4 n plus 1/6 n plus 2 2/9 n. And we're going to need a common denominator. The least common denominator, I would think, is 36. So the first thing we should do then is change all of our numbers to 36. And that would give us 24/36n minus 27/36n plus 6/36n plus 2 8/9 n. No, 8/36, sorry. Now this subtraction in the second term should be changed to addition. And then my best suggestion would be for us to go 2 terms at a time. If we have 24/36n and negative 27/36n, that would give us negative 3/36n. And let's rewrite the rest. 6 plus 6/36n plus 2 and 8/36n. And then let's combine the next two terms. Negative 3/36n plus 6/36n will give us 3/36n plus 2 and 8/36n. And we'll do that final calculation, and that'll give us 2 and 11/36n. In example 1, all we're really going to do is look through the steps because they've already been prepared for us. They're asking us to rewrite the expression in standard form by collecting like terms. So our original expression is 1/2 a plus 2 2/3 b plus 1/5 minus 1/4 a minus 1 1/2 b plus 3/5 plus 3/4 a minus 4 minus 4/5 b. Yes, that's a nightmare. But what we want to do is step by step follow the same guidelines we've been using all along, which is first of all to rewrite all of the subtraction as addition and changing the term after it to its opposite. So we do that one item at a time. Rewrite everything from left to right, 1/2 a plus 2 2/3 b plus 1/5, and we're going to change this subtraction to addition, plus, and you put the opposite sign, negative 1/4 a, And notice we put that in parentheses. You don't want to have signs next to each other and no parentheses. It's confusing enough without. And then we'll change this subtraction to addition, plus negative 1 1/2b. Keep rewriting, plus 3/5 plus 3/4 a. Change this subtraction, plus sign of the opposite, negative 4. Change this subtraction, plus, and the opposite, negative 4/5 b. Now, once we have everything rewritten as addition, we now can move our terms around and add them in any order because the commutative property allows us to add in any order. What we want to do is collect all of the a terms together. So we have 1/2 a, we have negative 1/4 a, and we have 3/4 a. And we'll put those all together because then we can group them using the associative property. Then we'll group together all the b terms, 2 2/3 b, plus negative 1 1/2 b, plus negative 4/5 b. And again, we'll be able to group them together using the associative property. And finally, then we will add together all of the constants, the numbers that don't have a variable. 1/5 plus 3/5 plus negative 4. And again, we will group them together using the associative property. Now, if you look at our next step, what you're going to notice is that we factored out the a. Each of these a terms is being multiplied by a. So we can take the fraction parts and add them all together, and then it will be multiplied times a. 1/2 plus negative 1/4 plus 3/4 is actually 1. And 1 times a is a. For the b terms, again, we factored out the b, and we have these mixed numbers together. 2 2/3 plus 1 1/2, negative 1 1/2 plus negative 4/5. After we got a common denominator would give us 11/30 times b. And finally, in our last step, we added 1/5 and 3/5 and got 4/5. And 4/5 plus negative 4 is negative 16/5. And that would be our final answer. There's nothing more that can be combined or simplified, so our expression in simplest form is a plus 11/30 b minus 16/5. And now it's our turn. It says, first of all, predict how many terms the resulting expression will have after collecting like terms, and then write the expression in standard form by collecting like terms. So the first thing we're going to do is predict how many terms we will have at the end. And I'm going to put that in parentheses. We should have, there is one variable, g, and one constant. So we probably will have 2 terms in our final answer. Now, the first step would be to rewrite all of the subtraction to addition. So we'll have 2/5 g plus negative 1/6. Change this subtraction as well. Plus negative g, which is actually negative 1g. And if you're struggling with that, just put a 1 in front of it. That might help. Plus 3/10 g, and changing this subtraction, plus negative 4/5. Next step is we need to gather all the like terms. So we're going to move all of the g terms together. 2/5 g plus negative 1g plus 3/10 g, and those are all the g terms. So then we'll gather all of the constants. Negative 1/6 plus negative 4/5. And on our next step, we'll go ahead and use the associative property to group them together, all of the like terms. And we have 2/5 g plus negative 1g plus 3/10 g. Well, in common denominators, that would actually give us 4/10 g plus negative 10/10 g, that probably will help, plus 3/10 g. And then common denominators for our constants, the least common denominator for 6 and 5 would be 30. And so what we're going to have is negative 5/30 plus negative 24/30. And now we can add. We have two positive terms here. 4/10 plus 3/10 is 7/10. And 7/10 plus negative 10/10 is negative 3/10 g. I didn't factor my g out, but hopefully you remember how to do that. And then adding the constants, negative 5/30 plus negative 24/30 is negative 29/30. And that would be our final answer. One more. All right, let's rewrite all of our subtraction as addition. And we'll make this negative 1h, because I think at this point that's kind of helpful for all of us. So if I plus 6i plus negative 3/7 I plus 1/3 h plus 1/2 I plus negative 1h plus 1/4 h. Now we'll collect our like terms. That's a capital I there. Let's change it to a small I. Collecting like terms, we'll have I plus 6i plus negative 3/7 I plus 1/2 I and then we'll add the h terms plus 1/3 h plus negative 1h plus 1/4 h. And then we can use the associative property to group all of our terms together. Oh, we didn't predict how many terms there will be at the end. Let's take a look at this. There's I, and there's h, and there aren't any constants. So there are only two different types of terms. Let's add them together. We have two fractions with different denominators. So 2 and 7 would be a common denominator of 14. And that's going to make this 6/14 And that'll make this 7/14. So when I add them together, they have 1i plus 6i, which is 7i, plus 1/14 I, and then our h terms, we have 1/3 and 1/4, and the common denominator for them is 12. So that would give us 4/12. And we'll go ahead and change this -1 to -12/12. And the 1/4 would be 3/12. Okay, we group those together. 4/12 plus -12/12 plus 3/12. This would give us -8/12, -5/12 altogether. And so our final answer, let's go ahead up here. Our final answer would be 7 and 1/14 I plus -5/12 I, or h, sorry, h. Example 2 is a real-world problem. It says, at a store, a shirt was marked down in price by $10. A pair of pants doubled in price. Following these changes, the price of every item in the store was cut in half. Write 2 different expressions that represent the new cost of the items, using S for the cost of each shirt and P for the cost of a pair of pants. And explain the different information each one shows. And so in example 2, the price of the shirt could be 1/2 times the original price minus 10, or we could distribute the 1/2 and make it 1/2 times the original price of the shirt minus $5. And the price of the pants would be 1/2 times twice the original price of the pants. Or if we multiply that out, we get 1 times the original price of the pants, or the original price of the pants. And as you could see, if we distribute and we actually multiply our expressions out, they're a lot easier to understand. Continuing with example 2, we're going to write 2 different expressions that represent the total cost of the items if tax was 1/10 of the original price. So starting with the price of our shirt, we have 1/2 S minus 5, because that was the price after we distributed everything. And then the tax will be 1/10 S. And as you can see, now we have 2 S terms, so we should combine them. And 1/2 S plus 1/10 S would give us 6/10 S minus 5. And we can simplify that to 3/5 S minus 5. For the pants, our final was just the original price, and then we would need to add 1/10 of the original price, and that will give us 1 and 1/10 times the original price. Now in example 3, the steps have been completed, and we are collecting like terms, so we're justifying each step. We'll take a look at the problem step by step. First of all, we changed all of our mixed numbers into improper fractions, and we changed our subtraction to addition. So 5 1/3 became 16/3. Change that to addition. 3 1/3 was 10/3, and we had put the opposite sign since we changed this to addition. And then there's multiplication between our negative 10/3 and 1/2 x, or the quantity 1/2 x minus 1/4. So what happened in this step was not only did we change the subtraction to addition, and changed our mixed numbers into improper fractions, but we also distributed the negative 10/3 across 1/2 x and negative 1/4. So what you see is negative 10/3 times 1/2 x plus negative 10/3 times negative 1/4. Our next step then would be to multiply the two areas that are being multiplied, because multiplication happens first. And negative 10/3 times 1/2 x will give us negative 5/3 x. That is simplified. It would have been negative 10/6 x. We simplified it. And then negative 10/3 times negative 1/4 is positive 10/12, which we simplified to 5/6. Next step then is to combine like terms. We have two constant terms. Constant means only numbers. So we moved them close to each other with the commutative property. And we made common denominators of 6. So 16/3 became 32/6. And then in our final step, with the associative property, we grouped them together so we could add them first, since it's all addition. And we added and got 37/6, and our negative 5/3 x stays the same. Following that same guideline, we're going to rewrite some expressions the same way. So we start with negative 6 1/3, and then we have to change our subtraction to addition. And the term after it has to become the opposite. And then we are multiplying times 1/2 plus y. And the next step is we will distribute the negative 1/2 times 1/2 plus y. So what we're going to have is negative 1/2 times 1/2 plus negative 1/2 times y. We'll do some calculations. Negative 1/2 times 1/2 is negative 1/4. And then negative 1/2 times y is negative 1/2 y. Last, we'll need to group our constant terms together. Negative 6 1/3 plus negative 1/4 And those common denominators would be 12. So that would be negative 6 and 4/12 plus negative 3/12. And of course our negative 1/2 y. And then finally, we have negative 6 and 4/12 and negative 3/12, so we add them together and keep the sign. And that will give us negative 6 and 7/12 plus negative 1/2 y. And that will be our final answer. In exercise 3b, we have 2/3 plus 1/3 times the quantity inside the parentheses. The first thing we want to do is change that subtraction inside the parentheses to addition. So that'll be 1/4 f plus negative 1 and 1/3 and then we'll need to distribute the 1/3 since it's being multiplied times the quantity. And we'll have 1/3 times 1/4 f plus 1/3 times negative 1 and 1/3, but we'll change our negative 1 and 1/3 to an improper fraction. So it'll be negative 4/3 and now we'll do some calculations. 2/3 plus 1/12 f. 1/3 times 1/4 is 1/12. Oops. Plus 1/3 times negative 4/3 would be negative 4/9. Then, using the commutative property, we'll move our terms around. 2/3 plus negative 4/9 plus 1/12 f. And our common denominator is 9. So I'm going to change my first fraction to 6/9. And when we add 6/9 and negative 4/9, we get 2/9 plus 1/12 f. And that's our final answer. In example 4, we're going to model how to write the expression in standard form using rules of rational numbers. So our original expression is x divided by 20 plus 2x divided by 5 plus x plus 1 divided by 2 plus 3x minus 1 divided by 10. Now, in order for us to work easily with all of this stuff, we've got to have a common denominator. So the first thing that we would do is to change all of our denominators to 20. And in doing so, we'll have to change the numerators as well. So x over 20 is our first term, nothing needed to change. In the second term, we had 2x over 5. In order to have a 20 in the denominator, we'll need to multiply both the numerator and denominator by 4. We end up with 20 in the denominator, and in the numerator we have 4 times 2x. The next term we'll have to multiply by 10 in order to get 20 in the denominator, and so we multiply the quantity x plus 1, and please notice that we're putting everything from the original expression in parentheses. This is really important, because if you don't do this, you are very likely to multiply 10 times x, but forget to multiply 10 times 1. And then our final term we're multiplying by 2 to get 20 in the denominator. So in the numerator, we have 2 times the quantity 3x minus 1. And again, make sure you put parentheses around it. After that, since we have all of the same denominator, we can write the numerators in one big long string. So we have x plus 8x, we multiplied that out, plus 10 times x, plus 10, which is 10 times 1, plus 2 times 3x, which is 6x, minus 2 times 1, which is 2. Now, I would also suggest that this be written as plus negative 2, since it follows what we've been doing all along. And then when we combine like terms, we would have 25x. X plus 8x is 9x, plus 10x is 19x, plus 6x more is 25x. And our constants would be 10 minus 2, or 10 plus negative 2, which is 8. So now we have 25x plus 8 divided by 20. Our final step then would be to take each of the terms and put them over 20 separately. So we would get 25x over 20, which we simplified to 5/4 x, plus 8 over 20, which we simplified to 2/5. The second way to do it would be to factor out the x and break all of the terms up. So x over 20 would be 1/20th times x. 2x over 5 would be 2/5 times x. X plus 1 over 2 would have to become 1/2 times x plus 1/2. And 3x minus 1 would have to become 3/10 x minus 1/10. And then we would combine all of our x terms, 1/20th plus 2/5 plus 1x plus 3/10, factoring out the x, and all of the constant terms, which would be 1/2 minus 1/10. Then you still have to get common denominators. Combine all of your fractions, and you end up with the same answer. If you evaluate the original expressions by substituting x equals 20, would you get the same number? And so we look at the substitution. And working down, you get 25 2/5. The same thing is true for the other method. Little practice. We rewrite this expression in standard form by finding common denominators and collecting like terms. We would start off by making common denominators, and our common denominator, least common denominator, would be 18. So if we multiply 3 times 6 to get 18, we have to multiply 2h times 6, which would give us 12h over 18. Change this to addition, and the number after it will have its opposite sign. And to get 18 from 9, you have to multiply times 2. Multiply the numerator times 2, we would get 2h divided by 18. And then our final term, we multiply 6 times 3 to get 18. So our numerator would have to be 3 times the quantity h, and I'm going to change this to addition, plus negative 4 divided by 18. Now once everything has the same denominator, we can write the whole expression, 12h plus negative 2h plus 3h, we're distributing, 3 times h, plus negative 12, which is 3 times negative 4, over 18. And this quantity, 3h plus negative 12, needs to be in parentheses, because that whole expression, remember, h minus 4 was over the denominator, so the whole expression will have to be over 18. Yes, actually everything is over 18. Next, we will combine our like terms. 12h plus negative 2h is 10h, plus 3h is 13h. And then we only have one constant term, which is negative 12. And that whole thing is divided by 18. Now in our final step, we're going to split those terms apart. So we would have 13h divided by 18 plus negative 12 over 18 can be simplified to negative 2/3. And that would be our final answer. In example 5, we have 2 times the quantity 3x minus 4 divided by 6 minus 5x plus 2 divided by 8. There are several ways to do this, and I'll have you review those on your own, following step by step, and determine which one is your favorite. But at this point, you probably need to determine which one you're most comfortable with and then stick with it. Your final answer will be 3x minus 19/12, or 3x plus negative 19/12. And finally, we're going to do exercise 5, a little practice with the same concept. If I have 2x minus 11 over 4, I'm going to get common denominators first. The least common denominator for 4 and 10 would be 20. So in my first term, I'll have 5 times 2x plus negative 11. Change that subtraction to addition. And that whole thing is going to be over 4. So we distributed the 5 across the 2x plus negative 11 and got 10x plus negative 55 over 20. Kept the subtraction still, and multiplied 2 times 3 to get 6. And now we're going to distribute the 6 over the x minus 2, and that will give us 6x that will give us 6x minus 12. Or at this point, I'm just going to change that to addition and change the sign of the number after it. And I'll take my first term and write it in here as well. So we have 10x plus negative 55 plus 6x plus negative 12. This was subtraction. So when we rewrite it, we get 10x plus negative 55 minus, and we need to put this in a quantity because we're subtracting the whole thing, 6x plus negative 12. Now, before we do anything more, we're going to have to distribute or change our subtraction to addition and change the sign of both of the terms inside the parentheses, because remember, we are subtracting this whole quantity. So we'll complete that, and then we can combine our like terms. And we end up with 10x plus negative 55 plus negative 6x plus 12. Because when we change this to addition, we change the sign of each of the terms to their opposites. We get negative 6x plus positive 12. We'll combine like terms. 10x plus negative 6x will give us 4x. And negative 55 plus positive 12, opposite signs, will give us negative 43. And in our final step, we'll split these two terms apart, and we would have 4/20ths x, which simplifies to 1/5 x, plus negative 43 over 20. And we can leave this improper fraction alone, or we could change it to negative 2 3/20. Either one is fine. Please practice with the different samples in the problem set. We only get better with practice in these.